Welcome to episode 5 in our 2021 Cryengine Summer Academy. As you can probably tell, I am not Roman Peretsogan. I'm Brian Dild, Cryengine Learning Manager, and I am sitting in for Roman who, believe it or not, is on vacation. Who does that? Today, we're going to show you exactly how to set up the player character in our little island game. And when I say we, I mean my friend Josh, who's going to introduce himself momentarily. We're going to do that by taking our third-person shooter template, the one that you see when you create a new game, and adapting it to be more suitable for jumping around in a platformer game where nobody gets shot at all, except by mosquitoes. They're digital mosquitoes, so you can use that cheap binary insect repellent. Oh, I already sound all technical and everything, but never fear, although we're going to be writing C++ today, you can follow along even if you've never written a line of code. Just pay attention to the line numbers to the left of the code, which will help you keep track of where we are, and pause as often as you need to so you can type. You will need to have Microsoft Visual Studio installed, version 2015, 2017, or 2019. Take your pick. If that already sounds scary, you can pause right here and follow this tutorial that will show you exactly how to install it step by step. It won't cost you a penny since Microsoft very thoughtfully provides a free version right here. Of course, if you are a C++ programmer already, kudos to you. You will learn a lot about working with the Cryengine codebase. My job today is to ask questions, which, as I am not a C++ programmer, should come naturally. And now I'm going to hand the microphone over to my colleague Josh to get us started.
My name is Joshua Nuttall. I'm a support engineer here at Crytek, and I provide assistance to internal and external teams in the realms of programming. Today, I'm going to take you through setting up the character in Breeze. A few things to note is we're not going to cover the templates in depth in this tutorial. I'm not explaining the concepts of programming, but more the concepts that we're applying to the project. You're going to need Visual Studio 2015, 2017, or 2019. Take your pick. And you're going to need to have Cryengine installed, and if you want to stay up to date with the current status of what you're seeing in the stream, you're going to want to have followed the existing tutorials up to this point. For this tutorial, we're going to build from the third person template under the assumption that you've already set this up and you've already started building your project from it. During this tutorial, we're going to have already applied the assets from Breeze to our project, so this step will be skipped over, but know that when you're looking at the template in this video, you're looking at it with the assets created prior already applied. Once you have all that, in the launcher, you can do Reveal and Explorer using this little cog, and this will take you to the folder with all the assets. But what we want to do is right click the Cry project and generate solution. This will open you a window like this, where using the drop down you can select the Visual Studio version that you want to use. In my case I'm going to use 2019 and click generate. Once that's done, the window will automatically close and you'll see this new solutions folder. You can open that, go into Win64 and you'll see game.sln. If your Cry project is named differently, then this SLN file will have a different name. For example, in GameSDK, we have the GameSDK Cry project, which would then generate the GameSDK.sln file.
I don't know about you game developers out there, but I do know at Crytek it's standard practice to rename our game.cryproject file to an abbreviated version of the name of our game, like, C3 for Crisis 3 or Hunt for Hunt Showdown. So if someone decides to do that after they've already generated their solution and, edited some code, do they have to manually rename this .sln file?
So the best practice for that would be removing the solutions folder altogether and regenerating it from scratch.
So removing the solutions folder doesn't remove any custom code that you've done?
No, that will not affect any of the code that you've added yourself.
Okay, great.
So open the solution file. Once Visual Studio is opened, you want to find the Solution Explorer. In my case it's on the right hand side, but you may find it on the left side around the same kind of location. Open this. We want to right click the editor and set it as a startup project. This means when we launch the game, we'll launch the editor. So let's do that to begin with and see what we get out of the box with the template. So now in the editor, we can go into the levels and open up the tropical island. And you'll see out of the box we start with a character that can walk and shoot, which you can see there. It can't jump, it can't sprint, and the camera is very close. So this is not ideal for what we're building right now. Hence why we're going to make changes. So you can press escape to exit that and close the editor and go back to Visual Studio. So you want to open up the Solution Explorer, go into the project, drop down the game and open up player.cpp. This is where all the functionality of the player is created, and there's a few things you want to change. You want to change the mannequin animation database file to be third person. Then we want to change the set character file so it becomes player character and then already entered depose bot. Next, you see the set controller definition file. This becomes player controller definitions, and then the set default scope context becomes third person character. So once that's done, you can then go to build and build solution, and what you should see is this changes the default character that the template uses. So if you now click to launch it and you open up a level, when you click play, you now see the new character in place and they can walk around correctly. They still can't run and they still can't jump.
You took away my gun, didn't you?
Yep, so the gun is attached to the player character. So when we changed the player character, he no longer had the gun attached to him.
This isn't going to help my pigeon hunting. I had big plans for those pigeons.
Should have picked a different game.
Fair enough.
So if we exit this and close again, there's a few other little things we want to change about the default template. So if we go down to initialize local player, you see the code for shooting bullets is still there, which is not something that we want in this game. So we're going to remove this chunk of code. So in my case, line 93 to line 128, which consists of the register action and bind action for the shoot of the bullet. So remove that to clean it up. And with that removed, we now no longer shoot bullets.
So in fact, I didn't have a gun, but I did still have bullets.
So whilst you had the ability to press the shoot button and perform the behaviors, this code would actually fail because you didn't have a barrel attachment to spawn the projectile.
But I did still have bullets.
But you couldn't use them.
So I couldn't throw them at the pigeons? I mean really hard, obviously. Do some damage.
Not unless you had a bone called barrel attachment.
It's just so complicated. In life you just pick up a stone and throw it at the pigeon.
Now with that done, we now have a clean template with the character that we intend to use. Now we can start adding some extra functionality to these templates. So first of all, let's go to the player.h and we want to add a new set of input flags. So we want to add sprint, which you want to shift 4, and we want to add jump, which you want to shift 5. These input flags are used as a bit mask so that when we do the input, it's easy to send it over a network and it's easier to check the resulting data from this. So if we go back to the player CPP file, you see under the initialize local player, we bind a few inputs. We want to register and bind the actions for the input flags that we just created. So let's start with the jump. So you want to get the input component, register action. It's going to be on the group of the player, and we're going to call this jump. It then takes a callback, so we're going to do this as a lambda function. It takes a activation mode, and takes a float for the input value. Once that's done, we then create the body of it, and inside here we're going to do handle input flags changed. First one it takes in is the input flag, and this is the flag we just created, so in this case jump. Then it takes in action activation mode, and this is the activation mode passed into the function. Then you want to make sure you do a semicolon after that handle input flags changed, then one at the end just to end the register action line. Now we've registered the action, we want to get the input component again, and this time we want to bind it to a key, so we do bind action. We want to make sure we get the same action, so it's on the player group, and the action that we created was called jump. Next we take the device name, so in this case we want a EAID, keyboard and mouse, and then we want the key ID that we're going to use, so in this case let's bind it to space. With that done, that's created the input for the jump.
So I take it because you're binding this action to something referred to as keyboard mouse and a space key, that this is specifically mapping to PC hardware?
Yes, in this scenario it's PC only.
So presumably people might want to also make it work on PlayStation and Xbox, so would you add lines pretty much just like this and just change, I guess, the controller type and the specific hardware button?
Pretty much. So we would have keyboard and mouse. You could change that to be, for example, Xbox controller. And then instead of the space key, you could do like left joypad forward or something.
Cool. I feel almost like a real programmer now. So techie.
It's very simple.
Gonna have C++ dreams tonight.
They're scary.
And it's gonna be your fault.
We want to do the same thing again, so in this case we can just copy this chunk of code rather than typing it out again and paste it. But instead of doing jump, you want to do sprint, which means the bind has to be sprint. On the input flag change, we're no longer jumping, we are sprinting. So you pass in sprint, and we don't want this bound to space anymore. We want to do this one on the left shift. So now we have the jump and sprint both bound to input. Now it's done, it makes sense that we go and actually do a bit more with this input. So if we go into the handle input flags changed, you see this sets a bit mask. You see it sets this bit mask called M input flags. This is then used further up, so if we scroll up, you'll see update movement request, which checks the input flags. We actually want to make a fair bit of changes to this stuff because, for a start, in our game we want to be able to move when they're in the air, where this only moves when we're on the ground. We also want to, rather than having a fixed movement speed, we want to add things like sprint and a separate air control for moving at a different speed in the air, which will make a lot more sense in a moment when we show you how this works in game. So first of all, let's get rid of this if check for the ground. Because at the moment we don't care necessarily if we're on the ground or not. So next we want to do an if check if the input flag contains the sprint. If it does, then we just change the move speed. So in this case, move speed now equals 30. As you notice, this shows up as an error because the move speed is constant. I want to make sure it's not a constant value so that we can change it in this scenario. And don't forget to end your lines. Okay, with that done, we now have sprint, which we'll demonstrate in a moment. So jumping is a little more involved. So after we've moved, let's look at the jump. Underscore P character controller, and we want to check if it's on the ground. We do this because we don't want to double jump or have infinite jumps. We only want to allow jumping when the player is grounded. And we want to get the input flags and just check to see if it contains the input flag for the jump. If it does, then let's create a velocity. So in this case, it's going to be vector 3. Jump velocity, and this is just going to be a vector 3. We want no movement on the X, no movement on the Y, and on the Z we want to move, let's say 15.0. This moves us 15 units when we jump. This will probably be quite a high jump, so we'll come back and change this later, but it demonstrates the functionality that we're trying to show. So next we want to get the player controller again, and we want to do change velocity, passing in the jump velocity that we just created, and then we want cry, default components, C character component, or character controller component, sorry, a change velocity mode. In this case we're going to do add. So if you F12 the add, you'll see the definition. You see there is both a jump and an add that we can use, as well as a set target. We could use the jump one, we don't for this tutorial, because the jump one removes any existing velocity and applies an upwards velocity instead. So it's more cancelling out your forward momentum and adding upwards momentum. For this tutorial, with it being a 3D platformer, we want to maintain forward velocity as we jump. So you kind of jump forwards, kind of like a long jump in a way. So with that done, you see we now have the code for jumping, the pre-existing code for determining the movement velocity, which gets used in the add velocity. With this done, we can now compile again and demonstrate how this currently works. So just launch it, load the level, and then when you play, you see we can move as normal. If you hold shift, you now move faster. Probably hard to tell, but you'll feel it if you're testing. And we have a jump, which is quite high. But something you notice is if we move in the air, you see he gets faster and faster the more we move. So if I jump again, you see he slowly picks what speed is in the air, which is not what we want for this tutorial. This is because when you're in the air, the player has no friction. When you're on the ground, you have friction against the ground. When you jump, this friction no longer exists. So we want to create a separate movement value for when you're in the air. So if we just close the editor and go back to our code, we want to do a second if check up here to make sure that when the player is not, m_p character controller is on ground. So this only happens when the player is not on the ground. And then within here we want to change the move speed to be, let's say, 5.0 for example, because we want them to be slower in the air. We then need to change the sprint to be an else, because we don't want to be able to sprint in the air. And with that done, we can now compile again, launch the editor, and when we play, you'll see when we jump, we still jump high, but we don't move anywhere near as fast, which is really useful. That way we don't fly forward when we're in the air. So with that done, maybe your artist would want to change these values. At the moment, to change the values you need to come into the code and change them here, which is all well and good for a programmer, but for an artist that's very confusing and very hard to do. So what we're going to do is going to create some cvars, console variables. So if you go to the header file, and at the bottom of the class, you see there's some variables that already exist. We want to add a few new ones. So these are going to be floats, we want a move speed, we want a airspeed, we want a sprint speed, And finally, we want a jump height. That should be nice and simple. Next, we want to go to the top where you see the constructor and destructor. These are going to change because we want to now implement these so we can initialize our variables. So remove the default for the constructor and the empty implementation of the destructor. Go into the CPP file, and for best practice, let's do it at the top. We want CPlayer component for the constructor, and CPlayer component, and then we want the destructor of that for the destructor. Okay, we're in here, we're actually going to do some initialization. We construct the values this way rather than in the body of the constructor. This way we don't allocate any resources to setting the default values. So there's no copy constructor applied or anything. This is initializing the defaults in the most straightforward and easy way for C++. So the move speed we want to be 20.5, the sprint speed we'll go with 40, the airspeed we want to be 10, and then for the jump height, let's set that to be 2.5, and just make sure that every element in this construction has a comma after it other than the final element, just so it compiles correctly. Next, we want to, inside the body, we want to register the CVARs for this. So this is done with register CVAR2, and we want to give the CVAR a name. So in this case, g_move speed. Take a reference to the variable that we created, so in this case, move speed. Then we want a default value. In this case, it's already been initialized, so we can just use the variable, any flags that we want. In this case, we want no flags, and a description of what this does. So speed, the player moves. And that. This is labeled as undefined, that's because there's some includes to add. So what we can do is hash include cry_system console registration, and that should include everything we need for these CVARs. So let's add some more. Let's add register CVAR2. In this case, we're going to do sprint speed. So g_sprint speed. Again, take the reference to the variable, the default, no flags in this case, and a description. So in this case, speed the player sprints. And it's the same story for the other values. Airspeed, take the airspeed, and no flags, give it a name, speed of the player in the air. That's good. And I imagine you get the idea, so we'll skip forward to when the next one is done and see if you could do it yourself. Now you have all your CVARs, let's go down to the destructor. And we want to handle cleaning up the CVARs once we're finished. So this is done through global environment under the p console, and there is unregistered variable is what we're looking for. And all this does is take the name of the CVAR that we created, which you can just copy and paste from the register CVARs. And you just want to do this for all the CVARs that we created. So in this case we have 4 of them, and just copy the names over. Essentially, when we construct the player component, we register some CVARs, and when it gets destructured, we unregister the CVARs. Nice and simple. Next, we want to go into actually applying these CVARs. So if you go back down to the update movement, you see we have these hard-coded values. Just change these to be the variables that we created earlier. So move speed, airspeed, sprint speed, and finally jump height. So now we can build that and test it, launch the editor, and then load the level so we can test. Okay, so once you're in, you can see we can move, sprint, and jump, and the default values are reasonable. If you press the tilde key, which is normally found to the left of the 1 key on your keyboard, you bring up the console. And the CVARs that we created earlier in code can now be accessed here. So we have, for example, g_move speed, and we set this to 200. We see it move really fast. If we set it back to 20.5, we move back at the original speed. So artists can come here and change these. Now you have those CVARs, artists can come in and change values with very little work. They can also be added to a system CFG or the Cry project so that you have the default values loaded when you launch the editor.
So a question about this, if the level designer, whoever it is, modifies the system config or the CryProject file and sets the preferred CVAR value, does that remain throughout the game? Is that preserved?
Normally, yes. What you set in the config would be applied across the entire game. But in our setup, this isn't the case because of where we created the CVARs. So at the moment, the CVARs are created when the player is constructed, and they're removed when the player is deconstructed or destructed.
Is that bad? Why is that a problem?
So the problem with that is when you change level, your player would be deconstructed, unregistering all your CVARs. Then you load up your next level, you reassign new CVARs with the default values. So your artist-driven values would not be consistent across the game because we remove the CVARs and we add new ones halfway through.
And when you say default values, I'm presuming you mean hard-coded then to the code, those defaults, not what was put in the system config file.
Yeah.
So you've kind of undone the whole beauty of giving the level designers or the artists the ability to set a preferred value that they've tested.
Yeah, in our case, this isn't a problem because the entire game is based around one map, one game type thing.
All right.
But in a bigger project with multiple levels or networking, you're going to want to move this to either like a standalone CVAR manager or something driven through the game plugin, not through a component.
Okay. So yeah, if it's multiplayer, then I guess players could come and go. It would also be a problem.
Exactly.
All right. I noticed that you used G underscore in front of your CVAR names, the custom CVARs. Why G?
The game.
Ah.
Everything is part of the game.
So game specific, not engine generic.
Yep, so for example, R for renderer, P for physics, it makes sense to do G for game. Now if we go back to Visual Studio, next thing you want to change is how the camera works. So at the moment the camera is very close to the player and is hard-coded in terms of location. So if you go down to the update camera, you'll see at the moment there's a view offset forward and view offset up. So what we can do is, first of all, let's create some new variables for these. So these are just, again, floating point, and just call it camera offset forward, and another one for the camera offset up. And then if we go to the constructor, we want to construct these. So camera offset forward, let's set this to be -4.5, and then do the camera offset up and set this to be 2.8. Next, we want to create two CVARs for these, so we can just copy and paste for now. And this is going to be G underscore camera offset forward, and we just paste in the offset forward, and then just give it a description. Let's call it offset from player in forward direction. Same thing for the camera offset up. Camera offset up, change the value that's used, and this is going to be offset from player in up direction. Next, just want to make sure we unregister these at the end. So just copy the names. Then with that done, we can go back down to the update camera function and put these to use. And you see the view offset forward and view offset up. We can remove these altogether, and instead we use the values that we created, so M underscore camera offset forward and M underscore camera offset up. There's a few other little things that you want to change in this code. So at the moment, as you can see, it all goes into this local transform. So both position and rotation are unified into a single transform and applied to the camera and audio. So what we're going to do is we're going to split this out. So we have a rotation transform and a translation transform. We add them together and then apply them. We do this because it gives us more control over the camera rotation independently of the camera translation. This can be useful, for example, if you want to do camera shake, you can just change the transform of the camera without changing the rotation. So first of all, we want to create a new matrix. So matrix 3.4 called rotation matrix, and just set this equal to C camera, create orientation YPR, and just pass in your picture and roll that's created early on in this function. Then we want to get rid of this chunk of code which creates and sets the rotation on the local transform. That's not needed no more. And then this next bit of code, where we set the translation, needs to be completely changed. So this is now going to be another matrix 3.4 called translation matrix, and that's equal to matrix 3.4 create translation mat, and just pass in the vector 3. Then the next time we want to create another matrix 3.4 called final transform, and this is equal to the rotation matrix times the translation matrix. You can take this final transform, and you see where we set the transformation matrix on the camera component, that changes to final transform, and when we set the offset on the audio listener, that also becomes final transform. Save that and build, and then when we run, load up the level, and when we play, you see the camera is now further back. And you have some CVARs, so you can do G_, camera offset forward. So we set this to -3, and you see the camera comes closer to the player. So now the artists have control over the camera location for the template. So now we have the camera set up correctly, we have the player movement set up correctly, and artists are able to easily control this. That's everything we're doing in this current tutorial.
That is very cool. I love that you've given artists control over the speed, the setup, the camera offset, right there from the CVARs. Very, very nice. That is it for this episode. A big thanks to Josh for the C++ lesson. I can't call myself a master, but I definitely learned a lot.
You get in there.
In the next episode, we'll continue the C++ section of this game to implement some game mechanics, including objects that the player can pick up and drop off in collection zones. Is that right?
Yep, so the next one is going to be gameplay specific stuff like bouncy pads, picking up fuel, and dropping it at a collection zone.
Cool. We'll see you guys then.